Long before I was a noted nuclear zaddy, I was a Fallout fan. I have hundreds of hours in each game. I've even gone as far as to work directly with Bethesda to science everything from mini nukes to giant laser beams. One thing that I was never able to science though, until now, is this iconic image. No, this isn't just Vault Boy. If the internet is to be believed, this iconic image is actually hiding some nuclear science in it. Is this a rule of thumb that in the event of a nuclear war could save your life? Or is it just a bunch of bleh? If the ghouls of the internet are to be believed, this iconic Vault Boy pose is much more than just a thumbs up. It's supposed to be a quick way to determine whether or not you are too close to a nuclear blast. You look at the mushroom cloud in the distance, you hold up your thumb, and if the mushroom cloud is bigger in your visual field than your outstretched thumb, you are too close. Now, too close is hard to define without a working knowledge of nuclear weapons, so let's start there. What about nuclear weapons is so dangerous?
Everything. They are clear existential threats to civilization.
Yeah, no, I know that, Arya, but like, specifically though.
Oh, beep boop.
From decades of testing, we know that the energy distribution during a nuclear blast is more complicated than just uranium going boom boom. Yes, most of the energy goes into blast like it does for conventional chemical explosives, but there are also significant and potentially lethal thermal and radiative effects. So, what too close to a nuclear bomb means, we'll have to take into account being far enough away from each energy mode. We're going to evaluate each energy mode and not just potential nuclear fallout like the meme focuses on, because fallout depends on much more complicated factors like wind speed and direction and height of burst, factors that you won't know just looking at a mushroom cloud. And in the event of a nuclear war, blasts that create fallout are not actually optimal for destroying cities, so we're going to ignore this aspect for now. So, what is too close? Too close to radiation will risk acute radiation poisoning and death. Too close to thermal will risk blindness, burns of all degrees, and in the limit, vaporization. Too close to blast will risk blunt force trauma and soft tissue ruptures. Now here's a question that I think is fair for this Fallout Physics 101 class that we're apparently having. Sit down in the back. Which aspect of a nuclear blast will travel the furthest and will therefore define the utility of this rule of thumb? Radiation is usually what we think about most when it comes to nuclear weapons, but is that actually what we should be concerned with here? Arya, throw the options up on screen. Think about it. I'll be right back. After a nuclear blast, how far the energy goes will be determined both by the size of the weapon and the environment that weapon is in. Now, while radiation may be what most people think about when it comes to the aftermath of a nuclear explosion, radiation actually has the shortest range of the energies involved. That's because high-energy particles and gamma rays are scattered and reflected by atoms in the air, and therefore don't travel as far. They can even be deflected back towards ground zero. And just a side note, ionizing X-rays at the instant of detonation are what produce the tremendous but relatively small fireball that we're not considering here. The blast wave and associated damage travels the next furthest. This is both because it has the most energy behind it and because human structures, biological and artificial, are extremely sensitive to any pressures over atmospheric or overpressures. Finally, it's thermal radiation that travels the furthest after a nuclear detonation, as the photons of light don't interact with air in the same way that high-energy particles do. The atmosphere is mostly transparent to visible, infrared, and ultraviolet light. That's why you can see things outside. Did you get the order correctly? Good for some of you. But keep in mind that this order would have been different in a different environment. We've tested nuclear weapons in space, and in space, there's no air, so there's actually no blast wave. Ultimately, we will use the distance at which thermal radiation is no longer dangerous to evaluate this fallout rule of thumb. Now, I could have Arya calculate all of those distances for different yield weapons, but she's having her liquid helium tanks refilled.
Teehee, It's so cold.
So instead, we're going to use this fantastic website that you've probably seen before, Nuke Map, by Alex Wellerstein, a nuclear historian. It has coded within it all of the complicated calculations that will allow us to simulate a real nuclear blast of various sizes and dimensions anywhere in the world, with all the attendant details. I'm going to select 3 differently sized weapons to compare. Let's start with yields from the only offensively detonated nuclear weapons, Fat Man and Little Boy. Then I'm going to make sure to display all the data that we're interested in, from a 100% safe from thermal effects distance to mushroom cloud height, both of which we will use to compare against our thummy thumbs. Do all this and detonate, and it looks like the minimum safe distance from a Hiroshima-sized blast is 4.66 kilometers away, with a mushroom cloud that is 6.58 kilometers tall. Of course, this all scales up dramatically if we use a weapon in the United States' modern arsenal, and apocalyptically so if we simulate the largest US weapon ever tested, the fusion bomb at Castle Bravo. With this data in hand, all we have to do now is take it and see if the internet was right about Vault Boy. With accurately simulated mushroom clouds and safe distances in hand, we can now use simple geometry to calculate what the visual angle of these explosions would be from our point of view, and then compare that angle to the visual angle of our thumbs outstretched in front of our faces. Remember, if the mushroom cloud at a safe distance is bigger than our thumbs, then this rule of thumb tells us nothing. But what are the chances that the internet would be wrong about something as complicated as nuclear physics? A flaw in Bethesda logic? Yeah, right. Aria, take us to the surface, please.
It's super dirty out there, but...
I know, just...
Okay.
A fun little rule of thumb is that if you take your outstretched fists and hold it against the horizon, it takes up about 10 degrees of your visual angle. You can use this to estimate how far the sun will travel in 1 hour. Now, it also just so happens that your thumb is about the same height as your fist, about 10 degrees in your visual angle. So, at this safe distance, for this fallout rule of thumb to be true, the mushroom cloud behind me needs to be smaller than 10 degrees. If a Hiroshima-sized nuclear weapon detonated behind me, it would produce a mushroom cloud yay big. From a simple equation that you can do at home, we can see that this would be a visual angle of 70 degrees. And so this fallout myth doesn't hold much irradiated water. You can in fact be much, much closer to a mushroom cloud than this rule of thumb says. Even if the bomb was much larger, produced a mushroom cloud that stretched a third of the way to space, it would still be bigger than your thumb at a safe distance. And furthermore, this advice isn't just wrong, it's useless. If you're trying to avoid thermal radiation from a nuclear blast, it travels at the speed of light. You would have literally no time to check something and then run for cover. And if you are avoiding a blast wave, you have just seconds to try to take cover, rather than hold out your thumb and check a nuclear bomb like a dingus. Look, this rule of thumb is fun. It fits with the dark humor of the Fallout series, but ultimately, it's a bit like Preston Garvey. Don't need it, don't want it. Until next time.
Now exiting the facility.
Thank you so much to the very nerdy staff here at the facility for their direct and substantial support in the creation of this here video. If you want to join us at the facility, if you want to drape on a silky white lab coat, possibly be replaced by a synth, get videos early, get private members only live streams with me, that's patreon.com/Kyle Hill to join the facility today. And hey, if you support us just enough, you get your name on RA here in every single video. And as you can see, there's hundreds and hundreds. How could I even pass the time? So one thing I kind of skipped over was the fallout of the Fallout meme, right? So the meme says that if you hold up your thumb, then you might be in danger of receiving radioactive fallout. But something I kind of glossed over was that if an adversary was going to destroy a bunch of cities and have the most effect on a population and its infrastructure, they would most likely be airbursts like we did in Hiroshima and Nagasaki. Airbursts create the most overpressure on people and buildings on the ground. A surface burst that would create the most fallout That's what we're talking about, vaporized dirt and debris and fall out over time. That wouldn't be very efficient in taking out an enemy, or not as efficient. And if you're trying to end the world, efficiency is definitely your number one priority, right? Right? Thanks for watching.